Good afternoon, class. Now, this part here, we are looking at the improvement of the gas turbine cycle by having two-stage turbine with and without a reheater. Okay, with the intercooler and regenerative part that will be in your part 3. So here, as you can see, okay, we have one compressor and two turbines. One of it is the high pressure turbine, and the other one is the low pressure turbine. So first, the ambient air or the air from the atmosphere gets into the compressor, and then it undergoes isentropic compression before it goes into the combustion chamber. So from state point 1 to 2 prime here, we have isentropic compression. And then in the combustion chamber, you have heat supply that happens at constant pressure. So here you have air-fuel mixture. So the things burns, okay, and then you have heat supply. So as a result, you have hot gas at the exit of the combustion chamber. So the heat supply during this process is from 2 prime to 3. So the heat supply will be CBG T3 minus T2 prime. So and then it goes into the first turbine, that is the high pressure turbine. And this high pressure turbine here is to drive the compressor. Is to drive the compressor only. So based on this shaft here, so the work output of the high pressure turbine, you can say, is actually equals to the work input of the compressor multiplied by the mechanical efficiency. Then after that, it undergoes an isentropic expansion through the high pressure turbine and then goes into the low pressure turbine at state point 4 prime. Then it comes out at 0.5 prime. So another isentropic expansion happens here, but this time the work output is used or converted to mechanical energy to drive a propeller or a generator. So we can say that the net work output is actually equals to the work output of the low pressure turbine. So if we were to calculate the net work output based on this, okay, that is work done from 4 prime to 5 prime, you can straight away take it as CPG, that is the specific capacity at constant pressure for gas, multiplied by the difference in temperature between the exit and the inlet of the low pressure turbine, and then multiplied by mechanical efficiency, because you have a shaft here connecting the low pressure turbine to the propeller, and another shaft that is connecting high pressure turbine to the compressor. So that is why based on these two sections or the shaft here, you need to multiply by its mechanical efficiency. So here you have state point 1 to 2 prime is isentropic compression, then 2 prime to 3, so that is your constant pressure heat addition, and 0.3 to 4 prime, that is isentropic expansion through the HPT turbine. And then you have state point 4 prime to 5 prime. Okay, so that is another isentropic expansion through the low pressure turbine. So these are the formulas that we have. Based on the diagrams, you can look at the schematic diagram that we have here. This is the A side. Okay, 1 to 2 prime is considered as the A side. So that is why you have CPA for the work input of the compressor. And then the work output of the high pressure turbine, that is work output of high pressure turbine is here. Okay, so 3 to 4 prime. Okay, though that is CPG, so this is gas and this is A. So that is from 3 to 4 prime. And then you have the heat supply, that is 2 prime to 3, that is also CPG and T3 minus T2 prime. Then you have this on your TS diagram. So when you look at your DS diagram and compare to the previous one, as you can see, here you have another pressure line that is 4 to 4 prime, 4 and 4 prime on this pressure line here, and this we call it as the intermediate pressure. So from 3 to 4, this section here, we can call it as the high pressure region, and 4 prime to 5 prime here, we can call this as the low pressure region. So from the TS diagram, as you can see, from point 1 to 2 prime, so this is the actual flow path of the process path of the A in the compressor, that is from 1 to 2 prime. So when you refer to this irreversible process, then you have to refer to its isentropic efficiency of the compressor, which I have explained earlier. And then this is the isentropic compression temperature pressure relationship. That is only when you refer to point 1 to 2, that is a straight vertical line. And then this part here, that is for the high pressure turbine, the same thing. 3 to 4 is the straight vertical line, so you have this isentropic relationship here between temperature and pressure. Remember this gamma, I would like to stress on this. This gamma should be referring to the gamma for gas, and this should be for the gamma for air. So this is the isentropic efficiency for the high pressure turbine. So the actual over the theoretical, and also this one as well, the actual divided by the theoretical. So therefore you have T4 prime minus T5 prime divided by T4 prime minus T5. So if you were to take the isentropic temperature and pressure relationship, then you have to refer to 4 prime to 5. That is not 4 to 5. This is 4 prime to 5. So you have to take the temperature at 4 prime over the temperature at 0.5 and then equate it to the pressure 4 prime or 0.4. You can have P4 prime or P4. It doesn't matter here because pressure at 0.4 prime and pressure at 0.4 is the same actually. So the gamma here is a gamma for gas. Okay, so that is for two-stage expansion or two-stage turbine. And then the next one is before that. Okay, so the next one is you have another combustion chamber, which we call as the second combustion chamber. The purpose is for reheating. Okay, for reheating. The rest is the same from 1 to 4 prime. It will be the same, only except from 4 prime to 5. You have another combustion chamber here, so you have an extra heat supply from based on this. Okay, so as you can see from the formula, so you have extra here Q4 prime to 5, which is also the heat supply, is equals to CPG. This is still the gas side. Okay, so CPG T4 minus T5 prime, that is the heat supply. So if you want to find total heat supply, you should take this value, this heat supply here, add it up with this heat supply to get the total heat supply. And then the network output is still based on the last turbine, that is the low pressure turbine. And then the work output of the high pressure turbine is still equals to the work input of the compressor. And remember, have to multiply by its mechanical efficiency. It's the same as for this also, the network output. That means because you see a shaft here and a shaft here, so that is why you have to multiply by another mechanical efficiency for the network output. And that this is the TS diagram that you have. And then when you compare to the two-stage turbine without reheating, this one is with reheating. As you can see, from 0.4 prime to 5 is a constant pressure heating. Okay, that is when it goes into the second combustion chamber. So the previous one, we have these lines here straight away go down. Okay, then you have the isentropic expansion here. But for this, you have another section here which is referring to the second combustion chamber, which is the constant pressure heating. Okay, so the same for the rest. Okay, and that's all for this section. Thank you very much. If you found that my notes is useful or my podcast is useful, please subscribe or like. Thank you very much. Bye bye. Okay, so this is the tutorial that I have. So the solutions or the working examples will be shown later. Thank you again. Bye bye.